Good morning, everyone. I see it looks like there's about 25 of us. I appreciate it. Special thanks to Jim Zell for connecting. Our focus today is going to be on eliminating CPU and I/O waste from your clients' mainframe environments safely, automatically, and with measurable ROI. We will introduce our approach, our tools, and our proven results across industries. It runs about 25-30 minutes, so I hope I don't bore you guys.
You're never boring, Chris.
All right, we are not new to this, guys. Critical Path has been solving mainframe performance issues for nearly 4 decades. I think our longevity reflects our ability to deliver and stay trusted over time. We've worked in some of the most demanding enterprise environments, Fortune 500 banks, IT service teams, and global financial institutions. We are just on the sideline an officially approved vendor as of last year. I believe these partnerships speak to the scale and the reliability of our tools. Our tools have been utilized to analyze workloads in more than 700 environments globally. This includes everything from single LPAR shops to multi-international ZOS estates. And this is the foundation for our learning model for our tools. This is how we've trained our models and refined our tuning logic on real-world mainframe data at scale. Our tools don't just run one-time scripts, they learn. TT and TTSQL continuously improve recommendations based on cumulative insights. Every enhancement we deliver is designed with one or more goals in mind: reduce CPU, improve I/O, accelerate batch, and more. It's not theoretical. Our changes are measurable, testable, and predictable. We are completely vendor agnostic. You don't need IBM, CA, BMC, or any other licensing relationship to benefit from our software, and we integrate cleanly into your stack without adding any risk or dependency. Finally, we're fast. Most clients see validated value in the first 30 to 60 days of implementation, and we do in weeks what normally would take months or even years to achieve, depending on how you go about it. There's no long implementation runway, and our proof of concept shows ROI very quickly. Let's start with what sets us apart. CPS brings AI-powered subsystem optimization that's non-intrusive. It's fast, and it's extremely effective. This performance tuning requires zero downtime, zero developer involvement, and zero guesswork. TurboTune is activated with a simple JCL submission. Once the analysis is complete, your team will receive a JCL wrapped around the enhancements, and an operator can implement and test as required in a test environment, and it's a simple handoff to change management. I know it sounds more simple than it typically is, but that's the chain of events. There's no need really to spin up a cross-functional team or to pause a development cycle. The execution's straightforward and it's owned by operations, so it should be simple if you're managing the site. We empower DBAs, not developers, to manage performance. This gives control to the teams who understand how workloads behave without actually bottlenecking in the development pipeline. You'll want to test the enhancements prior to implementation, but this can be completed without involving application teams for the most part. We don't touch your application code. That means no risk of breaking business logic or triggering any costly regression testing. I do want to note there is one optional enhancement type, the multi-row fetch out of TTSQL, that does require minimal code change if it's pursued, but the code's provided by our AI, and it's ready for testing out of the box. This is a high-impact function of TTSQL when it's used, but it is optional, and we typically only recommend it when the ROI is clearly justified to do so. We regularly deliver between 5 and 20% of global CPU savings. These aren't theoretical numbers. These are measured. They're measured in MSU, service units, and dollars. Our tuning addresses both SQL inefficiencies and vSAN misconfiguration. But you really don't have to take our word for it, guys. We show you in advance. Our POC proves the value before you ever spend $1 on the implementation process. All of the optimization is performed off-platform. This means for you guys, zero performance hit to the systems you're working on during the analysis period, and no risk to your production data. The DB2 cache data collection is the only overhead that we create, and it maxes out at roughly 1.5% or less, And I want to emphasize here that this is not a global system overhead. This is relative to the LPAR in which you're collecting the DB2 cache data. And you can see from the icon on the left, each one of these images reinforce our mission. We like to empower the operations teams, reduce load, we validate with proof, we deliver real savings, and we do it without disruption. All right, let's talk a little bit about cost performance here, cost and performance issues. We know that every enterprise mainframe is pretty much facing the same pressures. They have to control cost, they have to boost performance, they're supporting modernization, and they're doing this all while dealing with legacy complexity. And if you don't do it, the cost of doing nothing is significant, right? It could mean millions in avoidable licensing and operational waste every year. Inefficient DB2 queries and vSAM settings drive up MSU usage and monthly MLC cost. And without visibility into the inefficiencies, these same wastes continue unchecked. As DB2 workloads evolve, access paths, they naturally shift. But these changes, they typically go undetected. The performance degrades slowly over time, not because the coding is bad, but because the drift is invisible. Poor vSAM definitions create high EXCP counts and I/O drag. Actually, this is one of the most overlooked but impactful contributors to performance issues. Without the simulation tools that we provide, or where you get elsewhere, teams can't really predict the benefit of optimization before they commit to the changes. That leads to either inaction, which we already said is not really an option, or trial and error tuning, which can be slow and risky. That type of traditional tuning really depends on having a subject matter expert with decades of what we call tribal knowledge, and it can be slow. Analysis can take weeks, months, even years, and the results, they vary based on who's actually doing the job. Conventional tuning requires IPLs, elevated access, and code changes. From our perspective, this is all creating avoidable risk. Tuning responsibilities are fragmented, right? They're split across development operations staff, DBAs, and even third parties. And the lack of ownership can make sustainable improvement nearly impossible. Manual efforts often miss the forest for the trees, and huge savings opportunities simply go undiscovered. With automation and AI, CPS, Critical Path, uncovers these opportunities at a much larger scale. Legacy inefficiencies drag down cloud migration, container strategies, and hybrid IT. It's very difficult to modernize efficiently if your foundation is bloated and under-optimized. One of the most common complaints that we hear on a regular basis is that the batch windows never shrink. They just continue to grow. Well, this is a symptom of deeper I/O and access path issues that CPS addresses. All right, those are the problems, right? These are the ones that most of our clients come to us and say, please help us solve these. Now I want to look at some of how CPS tackles these challenges using minimal risk and maximum impact. All right, this slide's about partnership, guys. Optimization at scale, it's not just about our software. It's about aligning and alignment between tools, people, and processes. This model explains how CPS and the client, or in your case, the MSP, work together seamlessly. CPS brings the advanced technology. We have TurboTune for vSAM and I/O subsystem and TurboTune SQL for DB2. Our engine performs the simulations, identifies the savings, and generates the JCL and recommendations for enhancement. The client, or again in your case the MSP, remains fully in control. Your teams provide access and governance, and the DBA provides guidance to ensure that all of the DB2 optimization aligns with the internal standards of the client. We use our proprietary tools to automate the simulation and the optimization process. And this includes indexing, buffering, CI size tuning, workload analysis. It's all done off-system. We rely on your operational teams to coordinate the access to data sets and provide context around scheduling, testing regimens, etc. This includes identifying the key batch windows or the high priority SQL workloads. Obviously, we're not on site or in the system entirely. Our automation engine incorporates the logic that's been refined over decades. This is what allows us to optimize with such great precision and avoid the one-size-fits-all recommendation. Your team will ensure policy compliance throughout the engagement, including ensuring like I said, securing access to the listcats and the DB2 cache data that we would require for the analysis. This partnership model works because it's low friction and role aware. Everybody knows what they're doing. We do the primary heavy lifting while your team stays in the driver's seat, specifically on compliance and integration. What this does for the customer, I'm sure you hear this all the time. Optimization is what it is, but I'm going to run through some of it. So let's start with the bottom line, guys. CPU reductions is really what we focus on from a sales and a core perspective, right? We can directly lower your IBM, ISV, MLC, and your SLA-based software costs. It's hard dollar savings. These are not theoretical improvements. You're going to see your bills reduce. CPS helps you shrink your batch windows, improving your ability to meet the SLAs and eliminate those long overnight job overruns. This is really important in shared systems or on the high volume processing cycles. Our tuning improves resource allocation and reduces contention. The result is typically faster performance, fewer slowdowns, and a more responsive system overall. You don't need to change your applications to benefit. 90+% of our recommendations are implemented through standard JCL and existing change control, which equates to no risk. You'll begin seeing results in, like I said, 30, possibly 60 days, depending on the cycle. And of course, this means that you actually have to implement the recommendations, which is where we've seen, some, delay in priority, which we can have that discussion in another time. Most customers realize their full ROI or more, typically, in the same fiscal year, which is excellent. It pays for itself very quickly. Your team stays focused on the business priority, and we handle the complex analysis, simulations, recommendations, and even the JCL packaging. It's a light lift for you guys. The implementation is your core responsibility as the MSP. I will email a link to Jim that he can send out that shows an index recommendation request through TTSQL. It's about a 2 to 3 minute video, and it shows how incredibly simple the process is. I'll make a note to do that. So by improving performance and the predictability, our process generally strengthens the system stability. This reduces a risk of any unplanned outage and helps maintain your uptime. Our approach is 100% repeatable across LPARs, applications, and systems. Whether you're optimizing 50 data sets or 50,000 data sets, we can scale right alongside of you. Together, all of these benefits explain why our customers typically choose to come in for a POC and then remain for the full CPS engagement. It is fast, it is safe, and it's a cost-effective optimization that provides enterprise-grade results. All right, this is going to show the TurboTune process. We start with a simple data collection step. Your team will provide listcat information, which contains the metadata we need for the initial analysis. There's no application access, no production data. It's just data set and catalog information. Next, we benchmark each one of those data sets against over 1 billion records that we've analyzed over time. This allows us to flag anomalies and suboptimal settings that typically would otherwise go undetected. TurboTune quickly identifies data sets that have high I/O overhead and excessive EXCP counts, and this allows us to prioritize data set tuning for the maximum impact. We like to front-end load the engagement so that you're seeing the reductions in the most immediate amount of time. Our AI engine generates all of the recommendations, and they are specific to the client access patterns and the data set behavior. These aren't generic fixes, guys. We tune what needs to be tuned. We don't just go after the whole ball of wax. We also flag obsolete or misaligned data sets for cleanup, and this reduces catalog bloat and storage waste. And this can be really important in environments with a long operational history. We've seen data sets that haven't been touched in almost 3 decades or more. Before anything is implemented, we simulate the savings, CPU, I/O, EXCPs, even storage, and we return it in a projection report. This makes the engagement risk-free. You can make decisions based on data-back decisions supported by what is going to be an expected ROI for the project. The cost of inaction is significant, right? The sources that you see to the right underscore that properly configuring vSAN dataset parameters, it's not optional. It's essential. for the mainframe environment. Experts affirm that optimized vSAM settings lead to faster processing, reduced CPU, and measurable cost savings across the environment. The question is, do you want to do it manually yourself over the next 6 months, 2 years, or do you want CPS to handle the heavy lift for you? TurboTune makes vSAM tuning automated, intelligent, and low risk. It's one of the fastest ways to reclaim performance and cut costs from your environment. TurboTune begins by analyzing actual query execution patterns. The slide you're seeing is what we like to call the big three. These are the primaries in this software package. It's not just static code. Regardless of the number of predicates for an SQL, TTSQL can rapidly analyze and recommend an optimal index strategy to improve the access path. In fact, I think last week we optimized a client with an SQL that had 900 predicates. I mean, you got to do the math on that one. It's huge. We identify inefficient or missing indexes. We recommend new ones to reduce full table scans, and we flag unused or redundant indexes to eliminate overhead. The result is fewer full scans, better access paths, and faster queries across the board. Multi-row fetch. Many of the programs out there still use single-row fetch loops, right? Even in the high-volume SQL, which is unusual. MRF is especially valuable for heavy batch jobs, where reducing row-at-a-time processing can yield huge CPU savings. We detect these patterns, and we recommend a conversion to multi-row fetch. The benefits include reduced context switching, faster elapsed time, and improved batch and online throughput. And the best part, guys, we generate all of the code for you automatically. Your developers don't have to do it manually unless they choose to. I'm not sure why they would. This is the only component of our offering that will require a code change. And it is optional, but again, highly effective. You would use this function only when it's justified by ROI. The obsolete package removal. DB2 environments are always cluttered with unused packages and plans. We identify them, and we recommend the removal of those stale objects to reduce catalog noise and improve system hygiene. We know from the workload data collection what's being used and what isn't. And the benefits of this are rebind performance, compliance, and generally reducing administrative overhead. So these three features are the big ones for TTSQL, and alone they deliver tremendous value: index tuning, fetch optimization, and cleanup. And because our tools are smart and automated, your teams can achieve all of this with a relatively minimal lift. But even beyond the big three, TTSQL has an enormous functionality. And what you see here is the full operational range of the platform. I'm going to kind of speed through this page, but I want to point out a few highlights. You can copy stats across environments seamlessly to ensure performance tests match what you're doing between development and production. You can simulate a production-like DB2 workload in a test environment, which allows for safe validation of any changes that you're proposing. You can compare access paths between different versions of your SQL to see how that would impact your performance before you take them live. You can test everything in the sandbox, guys. Never disrupt production. And all of this is done off-system using our engine. DB2 is never burdened during the analysis period. It preserves system resources and ensures zero performance impact. TurboTune SQL is more than an index tuner. It's a comprehensive platform. It brings enterprise-grade results, I'm going to try again, simulation and automation to DB2 environments. All right, we all know security is a non-negotiable for mainframe environments, and it's foundational in how we built TurboTune and TurboTune SQL. This slide kind of addresses the most common security-related questions. So TurboTune only collects metadata from listcats. No sensitive application data, no business logic, nothing private. I know I've said it probably 3 times throughout this presentation, but I can't stress it enough. It's a safe product. This allows us, though, to optimize vSAM data sets without ever touching your production system or your data. Similarly, TTSQL works off DB2 cache data, which is statistical by nature. We avoid collecting anything sensitive very intentionally. If necessary, in a smaller shop where we need granularity, the software does allow for SMF to be used, but it would only be done with your approval and only when necessary. You guys are running the show. We do not run in any privileged state. no privilege modes, no supervisor state, no use of PSW keys. This preserves the system integrity from our perspective. It avoids exposing your environment to any additional privilege escalation risk, I guess. Our software does not require any APF authorization or use any MVS-provided system services. We maintain a secure, non-invasive footprint. That's kind of our goal. Zero reliance on system-level hooks. All of our recommendations are validated in a customer-controlled test environment before they're ever deployed, ensuring safe change management and keeping your environment, or keeping you guys in full control of the environment. In short, our approach is surgical, statistical, and non-invasive. And we've built trust in the industry by working with highly regulated industries across the globe. This slide's going to show you a kind of a flow of the proof of concept and how it works. We start on the TurboTune side on the left, and we start by giving your team a small JCL and an environmental checklist to collect the BSAM metadata using ListCat. You send that data back to us, and we run the full system, we run the full analysis off system. We provide a detailed savings forecast and a data set level tuning recommendations. Typically, we will provide 3 to 5 data sets as a POC. For basic testing, it's really meant strictly to prove the efficacy of what we do and show you that the process works. And through that process, we provide the JCL so that you can implement it quickly to make the changes in your test environment. After the validation, assuming we meet all of your expectations, we move into a different discussion point. If we hit a stumbling block there, we will circle back and revisit. DB2 is on the right side, TTSQL. This is split into 2 data collection phases. We start with phase 1. We send over some instructions. It collects the DB2 cast data. It includes an INST and a REX file. We analyze that data, and then we request a phase 2, which gives us the opportunity to further refine our understanding of what the execution patterns are. Based on that, we deliver a full recommendation along with what you can expect from a results standpoint. You test the enhancement in a non-production environment, and assuming, again, that the results are what we all expect, you can provide an optional 30 to 60 days of execution history, and that history allows us to accurately project savings in the context of the window that was collected, in the context of the phase 2 data. Again, if you approve, we proceed. If not, we'll circle back and try and jump through those hurdles. Guys, this is a zero-risk, data-driven engagement. Clients absolutely love that they can validate the value before committing to anything. Whether BSAM or DB2 or both, the POC process is a proven one. It's repeatable and it's client-led. All right, from analysis to implementation. This slide shows how our process works from a technical flow perspective, and it's very high level. On the top level, you'll see TurboTune. We begin, again, like I said, having the client run a small utility JCL to collect the ListCat. No application data. That file's uploaded to CPS. Our engine and our experts perform the analysis and generate the tuning recommendations, and then those recommendations are wrapped in JCL and delivered back to your team in PDS format, ready for testing. So you will upload and go to work on the TOS. The bottom half you see is TurboTune SQL, and it's a different animal. On the DB2 side, we use our ZOS SQL extractor software inside ZOS to pull that cache data. It's an innocuous program that's been used over and over. Again, we do not collect any application data, and we don't put in any system hooks. That cache data is sent via ZOS via TCP/IP from ZOS to a local peripheral server where TTSQL runs off-platform. The output is a clean set of SQL recommendations, index optimizations, batch-friendly enhancements, all sent directly back to ZOS, ready for your team to implement. All enhancements, obviously, are going to be first tested in the client by the client, and then submitted to change management using your existing change management process. Nothing goes to production, guys, unvalidated. Yeah, we like to say it's optimization that works behind the scenes quietly, precisely, and with very measurable results. What you're seeing now is some examples of the reports. The left panel shows projected savings from a BSAM tuning across 316,000 or so data clusters. Of those data clusters, roughly 25,000 were eligible for enhancement, and the projected CPU MSU savings topped at 8% annually. And that's a little below our normal average, which I'll get into in a second. You'll also see I/O overhead reductions, EXCP reductions, batch time reductions, and we even account for DASD recovery there. These are not theoretical numbers, guys. These are derived from clients' real catalog data. In the center panel, we provide a detailed breakout of the data set environment, cluster types, catalog errors, track distributions. It's a long list. But you'd be surprised how often through this process we uncover broken entries, unused indexes, high-impact files that aren't even monitored. The visibility helps you guys and the client clean up legacy debt while you're simultaneously improving performance. In the right panel, there's a DB2 SQL tuning example before and after implementing our recommendations. As you can see, the total cost dropped by over 50%, service units by 67%, and we completely eliminated the sort operations. We didn't just guess what to improve, guys. We tested it, we simulated it, we validated it, and then we delivered it with the expected savings. All of our results come with full transparency. This is what makes our POC so incredibly powerful. You get to see the improvement before you ever commit. This is how you eliminate CPU waste at scale, guys. No risk, full visibility. Again, you're going to see a proof of concept summary. This is actually a recent. Let's see. The first example shows an SQL statement whose CPU cost was reduced by an incredible 99.99% plus. This query originally consumed over 80,000 service units. We brought that number down to 7. This is the power of precision indexing based on real-world, real workload data. The second example you see is two additional statements. You can see the relative savings. The first statement saving over 83% in SU, and the second statement saving 95% of SU and 93% of CPU time. Now I want you to think about this. Multiply that over thousands or millions of executions annually. The savings are literally massive. The third example shows an enhancement of the VSAM dataset definition improvement. CPU time dropping by 27% and maximum runtime savings exceeding 90% in some jobs. This is a huge batch performance improver. And EXCPs were also dropped there. So across VSAM and SQL, global CPU savings range typically as a combination somewhere between 5 and 30%. We average roughly 13% across the years. Keeping in mind, these optimizations are usually missed or not even addressed by a manual tuning process. So imagine the gains you can make for your clients, if you apply these across all of your customer environments. Next, we're going to see just a compilation of case studies, and I guess when you get the deck, if you haven't gotten it already, you can go through them in more detail. This is an example we did for Citibank. They had a major problem in Singapore when they consolidated their data centers. Systematics was in the system, and they, for several weeks, could not deliver results. So their data center manager, we've known him for years, made a call, and they flew us in Singapore. We spent a weekend there. Over that weekend, we delivered 800 enhancements to their system, and we resolved 100% of their issues. And in the process, we saved them 40%. We showed a 40% DASD reduction, sub-second response times, and this actually enabled them to do the mass consolidation that they did, which created untold millions in savings. This is Northbridge Financial. They are a Toronto company. Mike Banner, nice guy, was nice enough to write me a letter. This is a relatively recent example also. They were experiencing a struggle with IAM licensing complexity and performance shortfalls, generally speaking. We migrated all of their IAM data sets back to native VSAM in a matter of weeks. We optimized them all off system, and we shifted to a system managed buffer. The outcome, no risk, guys, no risk to them at all. No client data accessed, pardon me. And the performance was better than IAM, while we eliminated the cost of IAM for them. So it paid for itself easily. Fortune 500 bank. Now, we don't obviously disclose every client unless they give us permission, but the interesting part about this engagement was that the client team initially indicated to us during our discovery call that they had no VSAM in their environment, not one. So we found that interesting, and we went in and did the initial assessment, and what we found was they had more than 1 million data sets, about 1.2 million VSAM data sets across the systems. 125 of those qualified as candidates for immediate tuning. We engaged, and the engagement actually didn't last that long because as we got through 20% of our recommendations implemented, we saved the client 4 petabytes of storage. We cut 10,000 hours out of their batch time, and we reduced their CPU usage by 3,500 MIPS. And most importantly, we did it all with no contention. So that's going to wrap it up for me, guys. Critical path, I'll just summarize. We help organizations drive down mainframe costs and elevate performance in both VSAM and DB2 subsystems. We do this with a combination of deep technical tuning. It's powered by AI and our expertise. High-level business outcomes like ROI, capacity improvement, and most importantly for us, end-user satisfaction. It is a strategic solution with a tactical precision. Our engagement starts with a no-risk, low-effort POC. We collect and analyze. This phase allows you to essentially test Turbo and Turbo Tune SQL in action, seeing firsthand how fast and accurate and non-disruptive it can be. We integrate very easily into your broader modernization initiatives, and actually a lot of the time that's why we get called, because people want to utilize this prior to a migration or as part of a broader initiative. Our model is designed specifically to minimize the lift from your teams while we're maximizing the impact. So that's it, guys. I appreciate your time and attention, and I am happy to field any questions that you have.